Good afternoon, ladies and gentlemen, and welcome to the first seminar of the second semester of 2021. This afternoon, I have the pleasure to have on board Mr. Eduardo Benalcázar from the University of Campinas, São Paulo, Brazil, who is going to share with us a little bit of the research that he's conducting in the University of Campinas and also in Delft University. So Eduardo is going to talk to us about syngas fermentation for large-scale ethanol production. And he got his bachelor degree in chemical engineering from the university, from National Polytechnic School in Ecuador. And he did his master's at Delft University of Technology in Life Science and Technology. And he's currently finished his PhD in chemical engineering at the University of Campinas in a joint program with Delft University. So his area of research is focused on the bioprocess design and assessment for biofuels and biochemicals production from renewable resources. So without any further ado, I'll hand to you, Eduardo. Thank you.
Hi.
Thank you for the introduction. I'm most glad to be here. And yes, I will start. See if that everything is okay. Yes, I think I am presenting now. So thank you for connecting to this link and listen to my presentation. So today I will talk about the journey that I have gone through throughout this past 5 years of my PhD. Right now I am in the final months of the PhD. And I will start. So my promoters are Rubens Maciel Filho at UNICAMP, Henk Norman at the TU Delft, and John Posada Duque at the TU Delft. And my project is called Syngas fermentation for large-scale ethanol production. First, I will give you a short introduction to let you know about the context within which my project has developed this time. Right, I want to start first by telling you what is syngas. So, what is syngas? Syngas is a gas mixture of these three gases, the carbon monoxide, carbon dioxide, and hydrogen. This gas mixture can be produced, traditionally it has been produced from the thermochemical conversion of fossil-based materials like coal, like oil, and natural gas, but it basically can be produced by from any substance containing carbon. For instance, renewable feedstocks like wood or agricultural residues. I put here sugarcane bagasse, but because sugarcane bagasse can be used. And also municipal solid wastes can also be used to produce the syngas. What is the syngas used for? Syngas traditionally, or complexes, they used turbines to generate electricity, so the syngas generate electricity. A more complex route is the production of chemicals and fuels using the chemical synthesis, Fischer-Tropsch synthesis. This is a chemical process based on catalyzers. So this is a mature technology now. It was developed some decades ago. And throughout the years, some drawbacks of this technology can be mentioned. And those drawbacks are that this technology needs high pressures and temperatures to work. So pressures around 10 atmospheres or higher, and temperatures of about 200 degrees, even more than that. one special weakness of this technology is the sensitivity of the catalyzers to the minor components of syngas, because if the syngas is produced from lignocellulose, the lignocellulose is not only formed by carbon, oxygen, and hydrogen, as the syngas is, but it also contains minor amounts of sulfur, chlorine, nitrogen, and these gases are very, they inhibit heavily the activity of the catalyzers used in this chemical synthesis. And another feature of the Fischer-Tropsch synthesis is that the product yield and selectivity heavily depends on the composition of the gas. Basically, on the ratio between these two gases, the carbon monoxide and the hydrogen. So these weaknesses that I have mentioned are the, let's say, the strengths of the replacement of the Fischer-Tropsch synthesis by a fermentation. So the fermentation of the syngas to produce fuels and chemicals is a technology that uses, of course, milder pressures of maximum 3 atmospheres, 1 atmosphere, and the temperature is around 37 degrees. Another strength of the fermentation with respect to the Fischer-Tropsch synthesis is that the microorganisms are not so sensitive to the minor components of the gas. For instance, the sulfur gases. The sulfur gases are actually a source of sulfur for the microorganisms. They are able to uptake these gases. One drawback is that the microorganisms are very sensitive to cyanide, which is also a product in the gasification of the syngas. In the fermentation, microorganisms are very specific on the substance that they produce, and the product yield is only partially dependent on the gas composition. We will see that later on the presentation, because this is something that we have addressed as part of the project. So that is why the fermentation of syngas can come as a good player in the field. So why else paying attention to the syngas fermentation? Because the microorganisms are able also to use a wide range of compositions of these components of the syngas. So as long as the gas contains carbon monoxide or hydrogen, which are the sources of electrons for redox exchange. The redox reactions are what are the source of energy of bacteria. Okay, bacteria are able to also take the carbon from the carbon monoxide and from carbon dioxide. So practically, this is the only energy and carbon source that the microbes need to grow and to produce products that are interesting for industry. So the versatility that can be used to produce the syngas is one of the strengths of the fermentation. I have included here the last one. Is the methane, the biogas can be also be processed to produce the syngas. But since the microorganisms are able to use the components of the syngas in different compositions, in different ratios, that can be also the strength of the syngas fermentation, because we can formulate the gas feedstock from different point sources. For instance, hydrogen itself can be produced from the electrolysis of water, yes, and also the three components of gas can be independently obtained from gas effluent.
Hi, everybody. It seems as if we have a problem with Eduardo, so we lost connection with him. So we're not quite sure what happened. So I apologize for that. So we're going to cancel today's seminar, unfortunately. Once we get in touch with him, we'll try to reschedule, and we will send you an email with the next available slot for the seminar. Once again, I'm really sorry for the inconvenience it might have caused you, but it's one of those things that might happen when you are using this sort of technology. From my side, I wish you all a lovely end of Friday, lovely evening for those we are in the east side of the world, and a lovely weekend. Thank you, and bye for now.